Hi, welcome back. So we are in chapter 3, HCC VO1 project. In this chapter, we're going to be looking at three important outlines. First, we'll be looking at a quick introduction into the project and the idea behind the research. Second, we'll be looking at the workflow of the project, maybe the essential design as well as the process within process block. And then finally, we'll be looking at the project execution. Let's go ahead and review the project introduction. So first of all, let's look at a quick introduction behind the story of the project and the inspiration for that. Essentially, actually, the story starts by understanding the chest X-ray image dataset. It is available. I will make it available for you as well. However, the scenario I would like to start up with by discussion over the idea of a diagnostic tool. Especially when it comes to health field, it is important to see the contribution of AI framework to this field, where there are tons of tools have been evolved and developed over the time and have helped actually many physicians and experts in the domain to actually make their tasks way more efficient and much more accurate. And one more important thing I would like to emphasize here, as I have said before, artificial intelligence, it's a framework. It is a tool. Actually, the entire mechanism have to be understood from this perspective when it comes to something quite a bit sensitive dealing with human lives. That's why I think it is important to understand that whatever tool we are trying to design, those are just only tools. They help the domain expert or the physicians in this case to actually facilitate the process of discovery or diagnosis on a certain case. So the problem that we are interested maybe to simulate, if you would have an image and this image should be representing a chest X-ray image. According to the physician or the doctor says, well, there are two possible outcomes when he or she look at this image. The first one is to classify potentially to be normal. Alternatively, the second possible classification could be a pneumonia. From AI perspective, this problem is a classification problem. We have discussed in many ways different kind of algorithm classification can actually handle. And in this particular case, it's a kind of a binary classification. It's a kind of a 0 or 1. The idea of classification should be very much clear to you if you have followed the book or the third book, Prediction from the Start to the End. If we would go back and check what is the source of the data, if I want to look at this image, there are two ways to categorize an image. As we said, it could be in a grayscale, it could be in RGB scale. These are things that we discussed earlier before. So that means I have number of rows and number of columns, right? How about the case of RGB? I would have three different matrices in a form of a tensor. Gray or RGB, the question is that, what are we looking at now? Well, if I would have access to the knowledge of the doctor, now the knowledge of the doctor is represented as so. A doctor is able with his or her own experience to look at this image. They find out certain patterns, and perhaps they are able by eyeballing from their experience, years of experience, to say, well, this image represents a potential for pneumonia, or maybe look and say, well, this is normal. But how about if the doctor is a fresh graduate, yet not the experience? Maybe it needs number of years yet to expose to too many pictures, then he or she would have that knowledge. Actually can give me the final call, is the patient him or herself? I will be seeing the patient case, well, he really turned out to be normal or pneumonia. So these are the two possible, scenario simulation I would think of. That's why when we try to set up the project or we try to design or understand the research question, we need domain expert. And what we want to do, we want to mimic the knowledge they have by actually creating this software or a solution. Because if this is true, if I would have this a new doctor or physician, But if they have the ability to have access to such tool, then all what they have to do is to pass this image to that tool that we intend to design, and the tool will make a prediction. Will say this is normal and this is pneumonia. Well, normal would be 30%, the complement would be 70%. That is what the tool trying to predict. And the doctor would then consolidate their own knowledge by justifying, looking carefully at some pattern. If the percentage is high, maybe checking with their colleagues, etc. We have seen before, and we spoke so many times about the history of the data, where we said history is the core or the main knowledge our tool then can understand. And history actually basically nothing but large amount of those pictures from previous cases where they have been known that one case to be normal, other case to be pneumonia. If I pass those two sets to the model and the model do some magical job and create that model, and this model then says, well, I am ready now to give me a new image that I have never seen before. Pass it to me. I will check out with my history and I will tell you what is the percentage of this new image that you are actually giving me as an input. It could be normal or it could be pneumonia. And this is the problem. So the researcher problem is put in word, given an image of X-ray chest, would you be able to design a tool, a diagnosis tool, to predict what is the potential outcome of this image to be normal or to be having a pneumonia? This is our research question, and this is the solution we intend actually to design or to do. Now, the question is, what kind of a framework we would like to think of before we even start talk about the technicality or the workflow? Number one, if we have access to large amount of data sets for both classes. Well, in my second step, I would design an AI framework. We'll handle to spell out a model. And we'll call this model for now, example, HCCV01. This is the name of our model. So what is HCCV01? It is, you think of it as a tool, as something looks like this. I would love to take this HCC, I will pass it to the third step, which is gonna be a desktop app, which has a GUI and it has a backend. Okay, they are connected in some sort of way. Now the client basically should be interacting with the GUI. And then the backend should have an access to this HCCV01 model. Well, the input is that an image. So basically, I expect that the client will be passing an image, and then the GUI will contact its backend. With the backend, will actually have an access to the HCCV01, and the HCCV01 will give a response with a prediction probability of normal or pneumonia percentage. First thing we want to do is to look at the technicality part, where we get this data from. Well, basically, we have somehow to contact people like my final client, but they are the stakeholders, the one responsible to sponsor this project. Next, we look and we have to be working on the framework. What is the technicality of the framework? Which algorithm we're going to be using? Finally, we'll be looking at the design of the desktop using, of course, essential tools that depends on the programming language as we discussed before or the framework we are intent to. So let's go ahead and work on the workflow for the project following these three important blocks. That's exactly what we're going to do next. I will see you then.